Hey everyone, and welcome back to the channel. Today, we're diving into a tool that has literally changed the way we see our planet, Google Earth Engine. If you've ever been curious about satellite imagery, environmental science, or big data analysis, you're in the right place. So, what exactly is Google Earth Engine? Think of it as a massive, cloud-based platform that combines a petabyte-scale catalog of satellite imagery and geospatial data with planetary-scale analysis capabilities. It's like having a supercomputer dedicated to Earth observation right at your fingertips. You can analyze environmental changes, map trends, and quantify differences on the Earth's surface without downloading a single massive file. It's used by scientists, researchers, and developers to detect deforestation, map water resources, monitor agriculture, and so much more. Ready to unlock its power? Let's get started. To really get a grip on Earth Engine, we need to understand a few core concepts. These are the building blocks for everything we'll do. First up is an image. In Earth Engine, an image isn't just a picture. It's a fundamental data object that can have multiple bands. For example, a satellite image might have red, green, and blue bands for visible light, plus near-infrared and thermal bands that we can't see with our own eyes. Each band is essentially a grid of values representing something measured by the satellite sensor. Next, we have an image collection. As the name suggests, this is a stack or a series of images. Imagine wanting to study a specific location over time. You wouldn't look at just one image. You'd look at a collection of images taken on different dates. An image collection lets you group these images together, making it easy to filter by date, location, or even cloud cover. This is super powerful for time series analysis, like watching a forest grow or a city expand over decades. Then we have features and feature collections. While images handle raster data, that is, pixel-based data, features handle vector data. Think points, lines, and polygons. A feature is an object with a geometry, like the boundary of a specific farm, the path of a river, or the location of a city. It can also have properties, like the city's name or population. A feature collection is simply a group of these features. You might have a feature collection representing all the countries in the world or all the protected areas in a region. Understanding the difference between images and features is key, as we often use them together. For instance, using a feature to clip an image to a specific area of interest. Alright, with the theory out of the way, let's get our hands dirty with some basic operations. I'm here in the Earth Engine code editor, which is a web-based guide for writing and running scripts. The first thing we usually do is load some data. Let's start with some Landsat imagery, which has been observing the Earth for decades. I can search for Landsat 8 in the search bar and import the collection with a single click. Earth Engine gives it a variable name. Let's call it Landsat. Now, Landsat contains millions of images from all over the world. That's way too much data. We need to filter it. I can apply a series of filters to narrow it down. First, let's filter by date. I'll use filter date to select images from, say, the summer of last year. Next, I'll filter by location. I'll use filter bounds and define a point or a polygon for my area of interest. Let's say, over the Amazon rainforest. I can even filter for image quality, like using filter mutator to select images with less than 10% cloud cover. After filtering, we might have just a handful of images instead of millions. To visualize an image, we can't just throw it on the map. We need to tell Earth Engine how to display it. We create a visualization parameters object. Here, we specify which bands to use for the red, green, and blue channels. For a true color composite, we'd use the red, green, and blue bands, but the real power comes from creating false color composites. For instance, by mapping the near-infrared band to red, we can create a color infrared image where healthy vegetation appears bright red. This immediately makes it easier to see plant health. I'll define my bands and set some min and max stretch values to improve contrast. Then, I use the map add layer function, pass in my filtered image and my visualization parameters, and just like that, the satellite image appears on the map. We can pan, zoom, and explore this rich data instantly. Now for the fun part. Data analysis. Visualizing data is great, but the true strength of Earth Engine is in its ability to perform calculations across vast datasets. One of the most common analyzers in remote sensing is calculating the Normalized Difference Vegetation Index, or NDVI. NDVI is a simple indicator that tells us about the health and density of vegetation. It's calculated using the near-infrared and red bands of a satellite image. The formula is near plus red. The result is an image where values typically range from -1 to +1. High positive values mean dense, healthy vegetation, while low or negative values often represent water, snow, or barren land. In Earth Engine, this is incredibly easy. We can take our satellite image, select the near-infrared and red bands, and then use the Normalized Difference function, telling it which bands to use. It will perform this calculation on every single pixel in the image. The output is a new, single-band image where each pixel's value is the NDVI score. Let's visualize our new NDVI layer. I'll create a color palette, maybe mapping low values to brown, medium values to yellow, and high values to dark green. I'll add this NDVI layer to the map using Map, Add Layer with our new palette. Instantly, you can see the patterns of vegetation health. You can spot forests, farmlands, and even areas under stress. And remember, we can do this for an entire image collection. We can map this function over every image in our time series to create an animation showing how vegetation changes through the seasons or in response to a drought or fire. This is planetary scale analysis happening in seconds. Once you've done your analysis and have a result you're happy with, you'll probably want to get it out of Earth Engine. This is where exporting comes in. Earth Engine allows you to export your results in various formats. For example, if you've created a beautiful NDVI map or a land cover classification, you might want to export it as an image file, like a GIF. This allows you to use it in other GIS software like QGIS or ArcGIS, or to create high-quality figures for a report. To do this, you use the export function. For an image, you'd use export image to drive. You'll need to specify a few things. The image you want to export, a description or file name, the scale or pixel resolution in meters, and the region or area to export, which is often the same polygon you used for your analysis. Once you run the script, a task will appear in the Tasks tab on the right. You have to manually click Run to start the export process. Depending on the size of the data, it might take a few minutes or a few hours. Once it's done, the file will be waiting for you in your Google Drive. You can also export vector data. If you've calculated statistics for different regions, say, the average NDVI for every country in a continent, you lines have a feature collection where each feature has a new property. You can export this as a table to a CSV file, a shapefile, or even a Google Sheet using Export Table to Drive. This is perfect for taking your summary data and creating charts and graphs in other software. Exporting is the crucial final step that connects your powerful cloud-based analysis with the rest of your workflow. So far, we've focused on the JavaScript code editor, which is fantastic for interactive development and visualization. But for more complex, automated, or large-scale workflows, you'll want to use the Python API. Earth Engine has a fully supported Python library that lets you do everything you can in the code editor and more. You can install it just like any other Python package using pip. Why use Python? It allows you to integrate Earth Engine into a larger data science pipeline. You can use familiar libraries like NumPy, Pandas, and Matplotlib to process your results. You can write scripts to automatically download and analyze data for hundreds of different locations. It's also essential for building operational systems, like a drought monitoring service that runs every week and sends out alerts. The syntax is very similar to the JavaScript API, so the transition is quite smooth. You'd initialize the library, authenticate with your Google account, and then write code that looks a lot like what we've been doing. For example, image collection Landsat LCR8 CO1 T1_senior is how you'd load the Landsat collection in Python. If you're serious about using Earth Engine for research or building applications, learning the Python API is an absolute must. And that's a wrap on our whirlwind tour of Google Earth Engine. We've covered what it is, its core concepts like images and features, how to load and filter data, perform a classic analysis like NDVI, and how to export your results. We also took a quick peek at the powerful Python API. This was just the tip of the iceberg, of course. Earth Engine is an incredibly deep and powerful tool, and we've only scratched the surface of what's possible. But hopefully, this gives you a solid foundation and the confidence to start exploring on your own. The best way to learn is to just dive in, find a dataset that interests you, and start playing. The documentation and developer community are fantastic resources if you get stuck. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and consider subscribing for more tutorials on geospatial data and environmental science. Let me know in the comments what you'd like to learn about next. Until then, happy coding!